recording. All right, so I'm recording. All right, guys. We are live. How's my audio? How's everything? Let's see. Okay, we are. Okay, we are live, and okay. So it's working. Let me know how the setup works. Change my thingy to okay. Yeah. So anyways, so today's gonna be quite a epic stream. Today we're gonna talk about our Aharonov-Bohm effect. All right. It's gonna be quite interesting, and I definitely think there's something to this. There's a whole idea behind scalar waves and all that jazz, but also just apparently scalar like vector potentials and electromagnetism and magnetism. Like, what in the world are those? I just want to see if this works. Okay, pop out. Oh, I can pop out chat now. Okay, so like, oh nope, I can't pop out chat. So yeah, so Twitter can't pop out chat for some reason. All right. So anyways, I'm gonna just ask all. Can y'all hear me? Hear me. Anyways, so you know, this Wednesday stream, I basically do the math science stuff if you have questions. But then again, my goal is to create 3 energy, and I'll be focusing on the math science stuff. Like just force myself to do this, and then gradually as it gets to 2030, it'll be full time. All right. Anyways, I'm gonna start standing now. All right, yeah, so we're going to cover that. Also, there's questions I had and so on. Okay, so we have, yeah, Jeff Strew says, nice, there's 0 people in the chat. I really don't care. We're going to continue on the journey. I'm going to go over here, and that is going to be, let me open up my notes here. So I had a bunch of notes here. Let's see what this link is going to open up. It's going to open up here. All right, so this is opening up here. This is a patent. From here, this is gonna be, and again, I had this opened up. So what's cool is what you can do with all these stuff. This is about yeah, so I have this pattern here. Anyways, so I have this open. I have a bunch of notes that I put in here, and I haven't double checked what they were, but they're pretty interesting stuff. So again, this whole idea, it's literally stems from this Aharonov-Bohm effect, or Bohm-Aharonov effect. So if we go, this is an it's a data patent 2016. This is from Lockheed Martin, and they were prior publication date. I'm not sure what that means, but anyways, yeah. So this was filed in 2011, so December 28, 2011. So it's like while everyone's in their Christmas holidays, you got these guys, military contractor, filing a patent for systems and methods for generating coherent matter wave beams. What in the world? So systems and methods for generating a coherent matter wave beam are provided, and in some aspects, a system includes a plurality of beam generating units. Each of the plurality of beam generating units is configured to generate a stream of charged particles. The system also includes a magnetic field generator configured to expose a plurality of streams to a magnetic field such that the charged particles of the plurality of streams undergo phase synchronization. So you synchronize a whole bunch of particles, as opposed to just light. You know, lasers are just light. Microwave masers are microwaves, like basically all in the same phase. So now you're doing particles with the same waves, phase synchronization with one another in response to a vector potential. This is the key part, associated with the magnetic field. So this is literally, I think, the whole idea where advanced propulsion, anti-gravity, and so on. I think everything, including advanced chemistry like cold fusion and all that, stems from. It's literally this mumbo jumbo. What in the world? Like, get a full grasp on this. Okay. Oh, I'm here. Okay, to me, someone how do? Okay. Epic stuff. Hopefully you like my Saturday stream on the MES Truth. I went over some pretty epic stuff there with the on the occult setups there. So it's fascinating for layman. I won't switch back to Fleetwood Mac. Okay. Yeah, this is pretty interesting. So I think this whole thing, I'll be trying to like wrap my head around this, but also like experiment with this, what this vector potentials are. So everybody hears of electrical and magnetic fields, but nobody knows like there's another aspect to it, vector potentials. Like, what in the world does that mean? And the plurality of streams directed along one or more channels combined with one another and produce a coherent matter wave beam. So you can like really fire electrons or whatnot, or protons, and literally have, and they basically have this whole setup here, whatever. But I want to go over, I'm going to go over, I thought there was a Lockheed Martin MP3. Okay, so what to understand some of this stuff, what I started doing was, if I go to MES stuff, okay, yeah, check out the Saturday show, yeah, epic stuff. Yes, I'll be posting basically my setup is, if the topic is conspiracy dominated, I'll move it to MES Truth. If it's science dominated, I'll move it to MES normal one. So, for example, if I'm talking about desification, like Hurricane Aaron, seismic evidence, that's evident. That's like scientific evidence that goes into here. But if I'm talking about, occult connections of 9/11 and so on, or like Epstein, Pizzagate, stuff like that, those goes on MES Truth, and so on. So, but anything if it's hardcore science stuff will be on here. But I want to go to the Hutchison stuff. So this paper, I actually threw this in here. I put this whole paper in here. I'm gonna find the better link here. So I made a post about this. So I'm gonna go right here. I'm gonna click right here. MES. I thought there's another Telegram. I'm gonna open up a new Telegram. Duplicate. Okay, duplicate this and put this here. Oh, and also, guys, here's the Threadcast. I'll be posting everything on the Hive blockchain. Even my Telegram posts, any big ones, I'm going to start posting on the Hive blockchain. So what I'm going to go is here. I'm going to search up Lockheed. Okay, so again, we have 2 hours to get in this. So this one here. So the 2011 Lockheed Martin patent for generating coherent matter wave beams references the Aharonov-Bohm effect, or AB effect, and associated magnetic vector potential dozens of times. See Grok AI table of definitions of concepts of the patent and Gemini AI podcast styled overview. So what I start doing here, I'm going to click here. So just to see the text layout version of this. So the whole idea is you want to basically, basically what it does is synchronizes a whole bunch of these setup here with these coupled resonating cavities mumbo jumbo, but it uses vector potentials to synchronize the same phase. So basically, like the peaks and troughs of the electron or proton or whatnot, the actual matter waves or ions or whatnot, those get in sync. And when you have that, you basically have a matter wave, like a matter laser, which is quite ridiculously powerful. Just for looking at that. But if you search this stuff here. If you go Aharonov, yeah. So now, this whole thing is based on this setup here. Aharonov, some macro test of the Aharonov thing. I'm going to go over one dimensions that did this. Okay, so figure 5 illustrates the Aharonov-Bohm effect acting on a particle. And if I click on here, so according to certain aspects, the Aharonov-Bohm AB effect may be used as a stipulant under a noise-needed resonance condition to induce coherence in matter waves. So basically, you're talking about this effect. The AB effect was predicted in 1959 by Aharonov and Bohm, and physically demonstrated by Tanaromoro in 1986. In a demonstration, a beam of charged particles is split into 2 coherent beams, where one beam travels through a field-free vector potential. So in other words, there's zero magnetic field there. And the other beam travels straight. When the 2 beams recombine, an interference pattern is observed, which shows that the phase of the beam that went through the field-free potential has been shifted. So basically, you can adjust the phase of particle beam, or charged particles. You can adjust the phase without a magnetic field. Like if you have a zero magnetic field and zero electric field setup, like in the zone when you have a magnetic field, basically you have a empty zone. And I'll be asking AI just to simplify this for me. So if you go Aharonov, and again, this matter waves AB effect, it's like literally everywhere. The AB effect is a demonstrated quantum mechanical effect that can be that can modify a physical system solely through its geometric parameters without exchanging any physical quantity. So think about what they're saying here. You can adjust things, again, without having a magnetic field or electric field, and nothing's actually being changed. So, also, did I just post something? I thought I was sharing this for next week. Okay. I accidentally had a scheduled post here. Okay, this was a scheduled post on my Telegram. Yes, I had a scheduled post. It was supposed to be for. Did I post another one as well? What is going on here? I thought it was supposed to be yesterday. Supposed to post. Okay, so I got those mixed up. Okay, so I have these two scheduled posts. Yeah, sometimes scheduled posts. This was I actually posted it. It's supposed to be yesterday at 10 a.m. But anyways, let's continue back to this Aharonov. Again, before I even get to what it is, I just illustrate. You got Lockheed Martin talking about this dozens of times. An AB effect is it's a quantum mechanical effect that can modify a physical system solely through its geometric parameters without exchanging any physical quantities. Imagine you could change something, like you could change a house, like turn someone around without anything exchanging. No air is being there, you're not throwing wind there, it just turns. According to the AB effect, the angular phase of a particle inside a vector potential can change even if there are no forces or fields acting on the particle as shown in figure 5. The AB effect, okay, so let's go to figure 5 in here. Okay, let's open up some figures. Let's go bigger here. Okay, let's go to figure 5. Okay, so that's all they show. What in the world is this figure? They just have some random thing changing. This is I think this is a field here, and then this gets shifted. I think the phase or whatnot. All right, so that's that part. But I'm gonna read over my Telegram post, and I'll have to put this on the Hive blockchain as well. So I'll be doing that just because sick and tired of this. Telegram, you need to like log in and download an app and see it. So anyways, the 2011 Lockheed Martin patent for generating coherent matter wave beams references the Aharonov-Bohm or AB effect and its associated magnetic vector potential dozens of times. See Grok AI table of definitions of concepts of the patent and Gemini AI podcast style overview. And again, so what I also did, again, go back to the Hudson hard drive. I think I have reports here, or science, I think. Science research. So on Grok, because I pay for the workspace for my like MES.fm email and so on. So that they give me, so what they do is they literally give me, what's it called? Yes, they give me free, well, it included the Gemini as part of my access to the AI, Gemini AI. And you can literally turn any report, PDF report, into a podcast. So it actually explains things so simply. So I think I had that. Where's the Aharonov? I think I put in here 2020s. Where did I put it? I think I definitely should have thrown in there science research. I'm going to throw it in here if I haven't done it already. I'm going to close some stuff here. Aharonov. I'm going to go and throw this patent in. I'm going to throw this in. Laser. Okay, matter wave laser. I thought I added it there anyways. Lockheed. I could have sworn I added it. Lockheed Martin room temperature laser. Yeah, this one here. So this one is, where did it put it? Oh, it's external. Okay, so there. Anyways, I just put it in here, and the patent as well. I'll patent this inside. I gotta throw it in here. Okay, I'm gonna delete this. The trash. Okay, move this in here as well. So that's the actual URL. All right, so now we have this. So I'll keep reading this thing here. It's actually very, very, very important. So here's the matter waves. So if you search up Bohm is like 12 times, and if you search up AB effect 17 times. So the AB effect is demonstrated quantum mechanical moment jumpers. All right, and also if you search up potential, it's everywhere too. So according to the angular phase, particle inside a vector potential can change and so on. So according to various aspects of the subject technology, a system for generating a coherent matter wave beam is provided. The system comprises a plurality of beam generating units disposed. Each of the plurality of beam generating units is configured to generate a stream of charged particles. The system also comprises a magnetic field generator configured to expose the plurality of streams to a magnetic field such that the charged particles of the plurality of streams undergo phase synchronization with one another in response to a vector potential. Again, these are the key points. Vector potential AB effect associated with the magnetic field, and 2, the plurality of streams is directed along one or more channels to combine with one another and produce a coherent matter wave beam. All right, so that's a mouthful. But I'm gonna play this. I made this from Gemini AI. Okay, I just like you upload the PDF and it just makes it. Just click here, and then what I also did was I made the AI generated podcast overview of U.S. patent. This one by Lockheed Martin on matter waves filed December 28th, 2011, and also used Camtasia AI for the transcript. So it's like AI everywhere, but to get a graph. So 6 minutes. I'm gonna actually play this whole thing. It's actually easier to learn what this all is than me yapping.
Welcome to today's exploration.
So these are actually two AI people. If you were told this before, like nobody told you this, and you just saw a podcast on YouTube, I think most people would think it's real people, but it's actually fully AI.
Welcome to today's exploration into the source material. We have a pretty wild one today.
Oh, yeah. It is definitely out there.
Yeah. We are looking at this stack of sources, mostly focusing on a specific patent from Lockheed Martin. It is U.S. patent 9,502,202.
Right.
And it describes a way to create what they call matter wave beams. So our mission today is to figure out how they have allegedly built a room temperature matter laser. I mean, imagine a beam of energy so incredibly dense that it doesn't just burn through steel, but it actually rearranges atoms, like with the precision of a 3D printer.
Which is a massive leap because, I mean, for a century, we've been absolute masters of the photon, right? Massless light.
Sure, yeah, lasers are everywhere.
Exactly. In a standard laser, every photon moves at light speed, regardless of its energy. They're basically like ghosts that can just walk right through each other in perfect step.
Right, but matter is a lot trickier.
Oh, matter is grumpy. With matter like electrons, where atom speed is tied directly to wavelength.
And that is exactly where the trouble starts, right?
Mm-hmm.
Because if I have an electron and I see you pulling ahead, I have to speed up to catch you.
Yes.
But the second I speed up, my wavelength changes. So my whole timing is ruined. It's kind of like a parade where every time a marcher tries to sync their stride with the person next to them, their leg suddenly grows 6 inches longer.
Okay, interesting. So matter waves like electrons, if you increase the speed, the wavelength changes. Whereas light, it always goes the exact same setup there. But then light as well, if you go through like glass or whatnot, it slows down based on its wavelength. I mean, it will change wavelength because it's gonna be slower. Yes, I think that's pretty interesting. But anyways, this is some AI podcast just to get overview of this.
That is a great way to put it.
9/11 Revision is in the show. 9/11 Revision is 6. All right, 6th channel. Epic stuff.
But the whole thing just becomes a chaotic mess.
Right.
And until now, the only way we could really fix that was the deep freeze method.
Yeah.
You know, Bose-Einstein condensates.
Oh, where you have to get everything super cold.
Right, down to near absolute zero, colder than deep space. You do that to force the atoms into a single quantum state. But the catch is that only works for bosons.
So it doesn't work for fermions.
Exactly. It does not work for fermions, which are things like electrons, the actual stuff that powers all our electronics.
Okay, but then we look at this Lockheed patent.
Yeah. Okay, so before this Lockheed Martin patent on AB effect, basically it's like you could do it at like room temperature setups. Instead of this, the Bose-Einstein constant, you basically super cool things, super cold, and then basically you'll have those in the same state or phase and whatnot. But this one you could do, you can make them in sync like electrons without even a magnetic field. It's a vector potential of a magnetic field, which again we have to wrap our hands what in the world the vector potential is.
And they are claiming they can do this at room temperature. Honestly, when I first read that, it sounded like they were claiming to have built a perpetual motion machine or something.
Oh, totally.
Because literally every physics textbook says room temperature is way too noisy for quantum synchronization.
Yeah.
So how are they, bypassing all that heat?
Well, they are using a quantum loophole. It is called the Aharonov-Bohm effect, or the AB effect.
Okay.
Usually, to move a particle, you have to hit it with energy, like a push or a pull. But the AB effect uses a magnetic vector potential to shift a particle's phase without actually touching it at all.
Wait. If there's no energy exchange, how do they even talk to each other? I mean, how does an electron know to sync up if it isn't being nudged?
So think of it like two cars driving down the highway in separate lanes.
Yeah.
To sync up, normally they would have to hit the gas or the brakes, right? But here, the magnetic field acts like this subtle, invisible curve in the road. Both cars feel the curve and adjust their steering to stay parallel, but they never actually have to change their speed.
Oh, wow.
Yeah. And because no energy is swapped, the wavelength stays perfectly stable. They kind of just see each other's timing through this magnetic shatter.
That is the big aha moment for the heat problem then. Because if you aren't adding energy, you aren't adding heat.
Exactly.
But what about the actual hardware? You can't just wave a magnet over a copper wire and expect a matter laser to pop out.
Definitely not. The patent describes this tiny housing. It is only about 10 microns long, which is thinner than a human hair.
Wow, that is incredibly small.
Yeah, and it uses something called ballistic transport. Basically, they keep the distance between the source and the target shorter than the mean free path.
The mean free path being the average distance a particle travels before it crashes into something.
You got it.
So it is basically a sprint. They want the particles to finish the race before they trip over a stray atom and lose their sync info.
Precisely. And they use a magnetic field of about 100 Gauss to bend these streams into specific channels.
Okay.
In that tiny space, the particles undergo phase synchronization in about 4 nanoseconds.
4 nanoseconds. That is fast.
It is the sweet spot. It is fast enough that the particles sync up before the ambient noise of room temperature can rattle them.
Okay, so you have this beam of matter, and it is all vibrating as one unified wave. What does that actually do for you? I mean, why should the listener care about a coherent electron beam instead of just a regular old electron beam?
Because of the n-squared rule?
Right, the n-squared rule.
Yeah, when waves are chaotic, their power just adds up simply. 1 + 1 = 2. But when they are coherent, when they are marching in lockstep, their power scales with the square of the number of particles.
That is huge.
It really is. If you have a billion electrons synced up, the intensity isn't a billion times stronger, it is a billion squared.
Which is just a staggering amount of energy density. And I guess that is why the source material mentions stuff like matter wave cloaking.
Oh, absolutely.
Because if you can control matter waves that precisely, you can theoretically guide them around an object. It makes it invisible to certain types of sensors.
Yeah, or use it for GPS-free navigation.
Right. We're talking about accelerometers so sensitive they could track a spacecraft's position to within centimeters just by feeling the quantum shift of these beams. No satellites required.
It is a total paradigm shift. It is moving from using matter.
Wait, this is I want to read that again. Did they just say you can have GPS-free position tracking? We're talking about accelerometers so sensitive they could track a spacecraft's position to within centimeters. Yeah, okay, because you have accelerometer. Basically, it's so sensitive. It's like, I'm just trying to say how would they work here. GPS-free navigation. Yeah, so basically, if you know your current location, and then everything's super, super sensitive, and it's all with this phase synchronization mumbo jumbo. So that's within centimeters, you can actually know your distance.
So sensitive, they could track a spacecraft's position to within centimeters just by feeling the quantum shift of these beams. No satellites required.
It is a total paradigm shift. It is moving from using matter as...
Well, actually, yeah, I think what it means is if it's all in the same phase, and as it's moving, that phase changes, but like the phase of the entire coherent system. So you can actually literally determine the distance traveled just by the coherent wave changing based on the speed and so on as it's going. So that's actually quite remarkable.
As just stuff to using matter as information.
Which makes sense. I mean, we've spent the last century perfecting the way we manipulate light in fiber optics to build the internet, right?
Right.
And this patent basically suggests we're about to do the exact same thing with solid matter.
It really is wild to think about. I mean, if we can now manipulate atoms and electrons with the exact same coherence we use for light, does the distinction between particle and wave finally stop being just a headache for physics students?
Yeah, and start becoming just another tool for everyday engineering.
Yep.
Well, that is definitely something to mull over as you look at the world around you today. Literally everything you see is made of waves. We might just be learning how to finally play the music.
Well, that's pretty epic Gemini AI setup there. That's actually remarkable. Okay, now, and I also used Grok AI to a quick summary of the terms, and then we'll go over some video tutorials and so on just to wrap our head around this whole Aharonov effect thingy. So this is Grok AI. I'm actually paste this stuff in here, copy this. I'm gonna paste this in here and the thing here. Anything I post, I'll put some in here as well. And I'll be posting this on the Hive blockchain as an actual article. This setup here. All right, so. Concept term, definition, description, as stated or directly derived from the patent. Coherent matter wave beam. A directed beam of low entropy coherent massive particles similar to laser beams but with concentrations millions of times higher than any intense laser beam currently available. Matter wave, de Broglie's waves associated with particles which may be subject to phase coherence. So phase synchronization, the process by which the phases of particles are aligned to achieve coherence without exchanging energy. And also, just to give you an idea of what phase is, so wave phase, for those who don't know what the phase is, it's just basically where it is along the setup there. Well, let's go to the wiki. Actually, let's go to the quick wiki here. Yeah, this is basically the phase along here. What would it be? Where's the phase? Yeah, this is kind of what I mean. Illustration of phase shift. The horizontal axis represents an angle phase that is increasing with time. So basically, you have this two exact same waves, different phases. So if you have so again, all matter apparently as a wave, it can act like a wave. So electrons, if you have a whole bunch of them, all of different waves, you can shift these so that they're the exact same wave, and that becomes and the power increases exponentially, not linearly. So I'm gonna go and post this. Here's phase. Let's put this phase shift. Let's go phase shift. All right. So that's that part. Send this here, and then also post it on here as well. Again, just to emphasize that is what the phase is set up here. And here's some other stuff. I think phase changing and so on as this goes in time. And that's some other phase diagram. Yeah, and where's some other phase? Real part of plane. Where's some other? Anyways, I just wanted to copy this. All right. And all right, paste this in, and let's go back into our journey there. All right, so okay, so phase synchronization, the process by which the phases of particles are aligned to achieve coherence without exchanging energy. Vector potential, a concept in the Aharonov-Bohm effect that can modify the phase of particles without exchanging energy. So this is the vector potential. That's a key part. Aharonov, the concept in it, the vector potential is the key. The Aharonov-Bohm effect, AB effect, a quantum mechanical effect that can modify a physical system solely through its geometric parameters without exchanging any physical quantity. The angular phase of a particle inside a vector potential can change even if there are no forces or fields acting on the particle. Phase shift, the change in the phase of particles due to the Aharonov-Bohm effect, enabling coherence without energy exchange. Bosons, particles with integer spins which can achieve coherence using the technology described. Fermions, particles with half-integer spins which can also achieve coherence using this technology, unlike conventional methods. I think fermions and bosons, let's see what a proton is. Let's go electron. I guess, again, what matters is basically electrons and protons. But then you can do, just because they're the common ones. So what is this one called? Is this one gonna fermion? Fermion. Yeah, so it is a fermion. Yeah, so they are, so electrons are fermions again. So again, that's basically you can do that. And then the other one is a boson. It's a proton. I think a proton is also a boson. Okay, so I think no. Okay, so here's the setup. Fermions is where would oh, these are elementary. Where is the protons going in? Particles and physics. Okay, so this is the table. Where's the protons in here? Okay, so photon is a boson. So again, then you have the Higgs boson. Oh, mom jumbo. So you have photons or bosons. Where's the proton? Positron in here. Up quark, down quark. Okay, okay. So proton is made up of these quarks. Okay, so it's actually would be considered a fermion. So one of those proton. So it's yeah, so it's called a baryon, nucleon, proton. Okay, so it's a hadron. It's these are composite. These are elementaries. Okay, okay. So yeah, so matter waves basically these are parts of it. So proton consists of quarks, which are fermions. So and yes, basically consists of an up, and a down quark. All right, so those are the actual So anyway, so proton is actually composite one. So you can have these internal ones actually coherent. But yeah, mainly electrons and so on. But that's quite interesting. Kind of like quantum teleportation. Yeah, a whole bunch of stuff like that. Particles with integer spins which can achieve coherence using the technology described. Yeah, I think if there is quantum teleportation, I think it's basically everything is using these scalar potentials. So it can move through without any force or fields being affected. So fermions, particles have integer spins which can also achieve coherence using this technology. So yeah, it's basically bosons, like again, photon, this one, electrons. So a boson Einstein condensate, a form of coherent matter wave that only works for bosons at very low temperatures. Basically, where's the bosons? Let's go back to the boson. What's this podcast you're playing again? What do you mean this podcast? Is MES Math Q or that AI one I made? That AI one I made, Gemini. Okay, so there's no podcast I was playing. The podcast is I made this one using Gemini AI. This one right here. These are two fake people.
So, welcome to...
Speed is tied directly to...
So those are two fake people I made with Gemini AI, and I fed them this patent, and it simplifies it in like everyday language, which is quite remarkable. Like, it's absolutely remarkable. It saves me literally years of research. All right. Okay, fermions. Yeah, boson. I'll go back to the bosons. Okay, so bosons. Yeah, so here's what I wanted. Okay, so bosons. You got photons. You got these gluon Higgs, and then you got hadrons. Are these whatever protons? These are composite ones. Fermions. Made up of quarks. These ones are made up of quarks. And then you have fermions and all that. Leptons, electrons. Okay, this is pretty interesting setup there. Yeah, so proton would be in between yeah, it's basically fermions made of a bunch of fermions. And mesons are made of a bunch of bosons. Alright, these are some ridiculous mumbo jumbos. I will be posting this here. And I'll be posting this here. Alright, and I'll be posting this, and I'm also gonna do I'm gonna archive this on Hive blockchain quickly. Let's see if this works. Archive on MES. All right, so just to archive these setups there. Okay, so it is archived. Bosons. All right, and then I actually bolded for some reason. All right, so that is that. Let's close this. Okay, look up entanglement engines. Okay, Rafael Sanchez, entanglement engines, non-commutative asymmetric time, quantum measurements proven to extract virtual resonant non-local energy. Okay, epic stuff. Yeah, we'll do that later. But again, we're dealing with Lockheed Martin literally got matter waves for cloaking and directed energy weapons and so on. They even say that too if you go here, directed. They literally said, examples of applications of coherent matter waves beams may include signal, bath, thermal energy extraction. So energy extraction, ultra-sensitive accelerometers, and interferometric tracking of airspace, aircrafts, a more accurate alternative to global positioning systems, matter wave projectiles and missiles, directed energy weapons, matter wave optics and cloaking, matter wave emission and propulsion, matter wave solitons, high energy collision, high precision matter optics, atomic clocks, tests of physical constants, and other suitable applications. Unlike lasers, where resonance may be the agent in phase modification for coherence, resonance alone may not modify the phase of massive particles without exchanging energy with them. In phase modification for coherence. Okay, yeah. So we'll do that. Yeah, so exchanging energy can destroy the monochromaticity needed for coherence. Okay, so exchanging energy will affect the coherence. According to aspects of the subject technology, the AB effect, a phase modifying process without energy exchange, can be used to modify the phase of massive particles and make the massive particles coherent. With the AB effect, the phase of the massive particles may be shifted without exchanging energy with the massive particles. All right, so that is that part. Yeah, so let's continue on this journey. Okay, so now the next setup, those are the fermions and also that. Okay, so Bose-Einstein condensate, form of coherent matter wave that only works for bosons at very low temperatures. Did I, yeah, anyway, a stream of charged particles. A flow of particles generated by beam generating units. The streams are directed and synchronized to form a coherent matter wave beam. Beam generating units, a component diode-like structure that generates a stream of charged particles, typically comprising a cavity formed between a cathode wall and anode wall with one or more intermediate walls. Cavity, the space within a beam generator unit where charged particles are generated and accelerated. Channel a pathway within the housing where streams of charged particles are directed and combined to form a coherent matter wave beam. These are just definitions I threw Grok AI for the patent. Electric field generator includes a main cathode, main anode, and voltage source to generate an electric field parallel to the channels for accelerating particles. All particles generated with the same non-zero kinetic energy. Housing a vacuum enclosure containing the beam generating units and channels. Synchronization rate, the rate at which particles phase aligns, influenced by magnetic coupling constant and other parameters modeled using the Aharonov model. It's pretty well stuff. So mean free path, the average distance particle may travel before colliding with another particle, critical for minimizing collisions and enabling ballistic transport. Again, that's why they have it like very, very thin in a micron level, that resonators or whatnot. Kuramoto model, a mathematical model used to describe the synchronization process of oscillators, applied here to particle phase synchronization. Core invention from summary and independent claims. The patent describes systems and methods that use multiple beam generating units to produce streams of charged particles, bosons, or fermions, like photons, basically electrons. Then, or quarks maybe. Then applying a magnetic field so that the particles undergo phase synchronization via the vector potential Aharonov-Bohm effect. The synchronized streams are combined along channels to produce a coherent matter wave beam. This approach works at room temperature for both particle types and achieves far higher particle densities than lasers or BEC, Bose-Einstein constantes. Yeah, so that's pretty wild stuff there. And I'm going to continue on. And now I'm going to go, I'm kind of going backwards. So we're getting the application side. You got direct energy weapons, Lockheed Martin, militarization of this technology. And now we're going to go over to the Thomas Beard in 1984 report. All right. And then I also use the Grok AI setup there as well. I mean not Grok AI. No, Grok AI. I use Gemini AI. Even definitions I use Gemini AI for this both. I'm going to click right here. And so now I'm going to read this one. And then we're going to go backwards and then just to show you the importance. And then actually figure out what in the world is a Aharonov-Bohm effect / scalar potentials and all that. Because it's quite ridiculous. Okay, this guy says, Sir John Pendry researches this. Interesting. Yeah, again, a lot of people research. And the way I do it, I'm like a very pragmatic. We were talking, Lockheed Martin is doing this. You got 9/11 was likely involved this technology. Well, in terms of like this specific technology, I think pretty much the scalar mumbo jumbos is the name of the game. Which can do a whole lot of stuff. I think a lot of that. I think even John Hutchison's setups. It's also the scalar part. Everyone just ignores. It's like what in the world is the scalar potential of a magnetic field? Like, what in the world is that? How come no one tells us that, or even like illustrates it? Okay. Anyways, so now this is this whole setup is from here. So also this one I'm gonna also put this as well. There's a second link, and I'm gonna click right here. So what I'm doing now is, not Beard, he doesn't really understand quantum physics. Look into Professor Bassel Hiley, non-commutative Hiley was Bohm's collaborator. He says Aharonov didn't quite understand. Again, I don't know what that means. I'm like, Thomas Bearden, he is working, he says a lot of stuff, but it's pretty interesting. Quantum non-locality is not scalar. It's non-commutative phase as quantum potential. I think you're well ahead of me. I'm just trying to wrap my head around all this. No, but Thomas Bearden is very, very, very good. He also knew 9/11 was done by this kind of tech. So this is again 1984. Just they called it Bohm-Aharonov effect, scalar interferometry and Soviet weaponization. This report actually, I read the report and then I fed it through the Gemini AI to make that podcast style to go over some of the terms. So I wrote amazing April 24th, 1984 report by Thomas E. Bearden entitled Star Wars Now, the Bohm-Aharonov effect, or Aharonov-Bohm effect, scalar interferometry and Soviet weaponization, and U.S. weaponization. Bearden outlines the electromagnetic potentials, which he calls scalars, are not just mathematical constructs used to derive the magnetic field, but are physical phenomena that can be manipulated and interfered with other scalar potentials to produce extraction or transfer of energy at a distance. And again, the Lockheed Martin literally states this, like literally states extraction at least. Obviously, you can transfer energy, but they said you can extract energy, I think, at a distance, as well as inertial or gravitational effects. A report highlights he worked with John Bedini. That's interesting. He actually thanks him The Soviet Union tested many, quote, cold explosions, hypothesizes a scenario where a massive electrical fireball were to hit New York City, literally in 1984. That's what he's writing in the report. References scalar weapons as a totally new kind of directed energy weapon. Okay, so we got this. And there references 5 Boeing 747 mystery planes flying through a giant mushroom cloud near Japan. So basically saying it's not radioactive. Cites radar invisibility and anti-gravity capabilities and much more. So videos, AI overview, Bearden 9/11, Bearden on a Hudson effect, and then we have Martin Fleischmann talking about the Aharonov-Bohm effect. So this is the paper there. I'll click this here. So here I downloaded this one here, put in the drive as well. So again, here's what I mean. You could literally just says summarize. You can make a podcast in here. Where's the make a podcast? There should be an option here. Okay, yeah, this one here, create an audio overview, and it does the podcast style. So here it is. This one's pretty fascinating report. There's a whole bunch on here, and again, spinning chart. They talk about this setup, but a lot of it is the Bohm Aharonov effect, and it approved for release in 2003 after 9/11. So they released it after 9/11. That's actually fascinating. Can you link the patent? Yeah, the patent is well. Here's the patent. I'll send you. This is the link to. Let's go to the patent. Lockheed. Actually, no, I already did this already. It's right here. So the patent is this right here. If you have my Telegram, you can open up this is the link where I made the post and the video, the podcast, and all that. And the patent link is inside it. You can go right here, and that's the patent link. Yeah. It's somewhere, yeah. It's just U.S. patent, blah blah. All right, and let's go back into what in the world is going on here. Why does this have? I don't want that. Okay, let's go back here. So there is the whole patents and so on. Anyways, continue on this. All right, so let's go back into this report by Thomas E. Bearden. So Bearden outlines, all this electromagnetic potential. That's the key part. It's like everything is literally there. Scalar interferometry is just, again, Bohm Aharonov effect. So abstract, so beams of pure potential without vector force. So the Bohm Aharonov effect shows that even in the absence of electrical and magnetic fields, the potentials cause real effects to occur in the field-free regions. Using this principle, beams of pure potential without vector force fields, without E and H magnetic electric fields, may be deliberately produced and intersected at a distance to cause effects in an interference zone. So you can interfere actual field-free vector potentials at a distance to cause effects in physical reality. In contradiction to classical mechanics, you can actually cause it at a distance in interference zone. These effects are in fact required by quantum mechanics. Essentially, energy may be produced directly at the distance interference site or extracted from it without energy transmissions through space. Implications for weapons built on these concepts are given, and several types of such scalar electromagnetic weapons are discussed. The use of the cold explosion, keep that in mind, the cold explosion is detailed, and the evidence of its extensive testing is given. The basic mechanism for Soviet weather control over North America is briefly presented and a more extensive reference given. So you get weather control, but again, he's blaming Soviets, but it's like U.S. literally doing this as well. They're all one and the same, right? Evidence of massive Soviet weaponization of these effects for nearly 3 decades and of Soviet scalar electromagnetic weapons testing on a global scale exists in the open literature. Selected examples and related information are given in the appendix. But again, interesting that this was released 2003, all right, after 9/11. So imagine this was released before. It was like, hey, wait, was it 9/11? Just this? So note also that a cold explosion of over 150 miles diameter represents an interference zone of about the size of the heart of the main troop deployments in the NATO central region. Yes, basically you can destroy an entire troop deployment just with a cold explosion. A single shot of such a weapon could almost instantly freeze every NATO soldier in that area into a block of ice. Note all, basically you're extracting energy from it. You literally freeze everybody or turn them to dust, as the 9/11 happened. So note also that the heat energy is extracted throughout the space-time of the area. Insulation or external heat sources are of no defense. Is extracted through the space-time area, so you can't actually insulate from it because it's not taking it like from an actual the heat off you. It's literally taking it from like the fabric of space, of the ether directly. It's like, that's because you're not using any magnetic field, electric field. It's literally like a non-field thing. It's like a vector potential, whatever that means. We'll get to that in a bit. Again, we have another hour and 15 minutes. The heat literally is sucked out of the interior of the bodies in the interference zone. Several such cold explosions shots could finish off the entire NATO central region, again in seconds or minutes. And since the Soviets would have given NATO no nuclear provocation, it is doubtful that a US president would launch a strategic nuclear attack against the Soviet Union in such an eventuality, particularly if monstrous cold explosions appeared without warning in densely populated regions of the US. So it's literally telling cold explosions happening in densely populated regions of the US. Like, are you guys reading this? Am I the only one? Like, this is like, and again, this was released after 9/11. But this was written in 1984, so it's released after, because if people were reading this, it'd be like, Thomas Bearden, you gotta come speak to Congress. But again, at Congress, they're all this bunch of clowns. So particularly if monstrous cold, and then also again, Thomas E. Bearden was told about Dr. Judy Wood's work, and he said, "Yep, that's right." So this is the Thomas E. Bearden. Again, I have inside scoop on him. Particularly if monstrous cold explosions appeared without warning in densely populated regions of the United States. In fact, one may argue that the Western military and civilian leaders would not even grasp what was being done to them, or who was doing it. Again, it's literally 9/11. Of course, the same scalar interferometry can be used in the produced energy mode. So you can use produced energy, or you can turn people to dust. In which case, it can jam or knock out almost all electrical equipment in the target zone. Oh, this is producing energy. Yeah, this is again, this is taking energy out. Now it's producing energy. In which case, it can jam or knock out almost all electrical equipment in the target zone. Again, similar to 9/11, a lot of electromagnetic stuff happened. Detonate explosive materials. Therein, note that a massive electrical fireball, say several megatons, over New York City would give all the desirable effects of a nuclear weapon without any of the desirable effects, undesirable effects, like radiation and so on. So he's literally saying you can literally turn things to dust, and you can also produce energy. In other words, make electrical cold explosions. Yeah, this is a cold explosion, yeah, but this is also, you could also have a massive explosion, like a fireball, like electrical fireball, like the quote plane impacts, those plane explosions. It would give the thermal radiation, the blast wave, and the EMP effects, but would not give the gamma radiation and nuclear fallout. So it would burn up and blow down things, kill people, and knock out electric systems, but would not do the radiation. So again, the lethality of the jammer transmitters vastly expanded by such adaptation. Indeed, jammer transmitters using scalar interferometry techniques are capable of attacking most military targets, such as tanks, aircraft vehicles, installations, fuel dumps, ammunition dumps, inflammable supplies, personnel. The jammer transmitter itself becomes a totally new kind of direct energy weapons, having nuclear ubiquitous military applications. Yeah, these and other implications of scalar electromagnetics have already been pointed out by this researcher. Examples of testing of scalar electromagnetics are given in Appendix 1. Again, 9/11. If continuous energy is fed into the transmitters of the scalar interferometer, then continuous energy emerges in the distance interference. So you're feeding into it one direction, it's popping out somewhere else. For narrow beams and substantial input energy, the distant energy density can be made quite high. Physical destruction of distant targets can be accomplished in this fashion, and the effect can be produced directly inside bunkers, directly inside buildings, tanks. You can literally make an explosion within a building from a distance, not like penetrating it, just explodes. Tanks and armored vehicles, aircraft, nuclear-tipped missiles, ships. Relativistic effects such as a change in the rate of the flow of time and the inertia of an object and in the mass of an object can also be obtained, at least in theory. In theory, the speed of light in vacuum can also be changed, and there's already experimental evidence of this effect. All right, anyways, here's some more lists that he did of examples. Mushroom cloud from sea off Japan. So he said 740 Boeing 747s flew through or near the cloud. So in other words, no contamination and non-nuclear. Ocean 21,000 feet deep. Too deep for submarine volcano to cause cloud, indicates man-made phenomena. Yeah, so it's super, super deep, so you're not going to say it's a volcano. 77 other such plumes since 1974. 77. In Soviet Union, in non-volcanic area, non-nuclear. And he has some other setups here. AC, Q radar. Chat disconnected. Okay, chat's disconnected. We should be back on. So, okay, we're back on. ACQ radar transmitter energy bottle interference pattern between Fourier expansion patterns. Energy captured, no reflection. So you can actually capture any of these radar sensors so and nothing gets reflected back. Creating an inertial field, anti-gravity, scalar resonance phenomenon, unidirectional. Okay, yeah, a whole bunch of setup here. You can basically interfere a bunch of these setups there, and you can get a anti-gravity zone. Okay, now I'm gonna play the Gemini AI I made of this. It's actually so amazing. This was the first one I made. Yeah, and I was just wondering, I'm like, hey, let's try this. So again, I fed this entire this article in there, 43 pages. Fed that in there. I'll just right here. So, I just did the thingy on Gemini, where you can turn this audio, create an audio, and you can do that podcast style that you can listen to anytime through Drive. It's actually remarkable. So I'm gonna play this right here, and let's play this.
So in April 1984, commercial pilots flying off the coast of Japan saw something absolutely terrifying.
Yeah, a massive mushroom cloud, right?
Exactly, like 150 miles wide, shooting 60,000 feet into the air. It looked exactly like a nuclear detonation, but, and this is the crazy part, there was no blinding flash, no heat, and absolutely zero radioactive fallout.
Which makes literally no sense under conventional physics.
Right. So today, for our exploration into the source material, we are diving into a 1984 report by T.E. Bearden, and he suggests this wasn't some weird volcano or a mystery bomb, but actually a demonstration of, well, phantom physics.
Yeah, he's talking about weaponizing potentials, which sounds like a sci-fi ghost story, but he roots this in a real quantum discovery, the Bohm-Aharonov effect.
Which basically says space isn't empty, right? Like the old idea is that energy has to travel like a bullet from point A to point B.
Exactly. But to really understand Bearden's report, you have to flip your perspective. Mainstream physics treats these potentials as just convenient math shortcuts to calculate force fields.
I like to think of it like the ocean. Like classical physics only cares about the waves crashing on the surface, right? Those are the electric and magnetic fields we can actually measure.
Right, but the Bohm-Aharonov effect implies the real power is the deep sea pressure itself, even if the surface is totally still.
So if the force field is zero, what exactly is moving the particles?
Well, that is where his concept of scalar electromagnetics comes in. Instead of the typical wiggling waves we use for radio or light, these are longitudinal. They're non-Hertzian waves.
Like sound waves, maybe just rhythmically compressing and stretching the actual vacuum of space.
Yeah, exactly like that. Bearden actually calls it squeezing the massless charge of space-time.
Okay, but let me...
Okay, yeah, so and now if you look at an ether model, these scalar setups could be, again, longitudinal waves. If light is a transverse, like up and down, like a wave on the ocean, the actual longitudinal pressure pulses, like sound, but through the actual ether medium of space, etc. That could be what this whole vector potential mumbo jumbo is. So yeah, but one analogy is, think of the vector potential as the ocean, and then the waves are the electrical and magnetic fields. Again, that's where this AI-generated podcast gave me the idea of that. I'm like, that helps you actually visualize some aspects of it. Let's play it.
Let me push back for a second here. Because if this was discovered back in 1959, why isn't this just standard high school physics? Like, are we just looking at a mathematical quirk that Bearden is blowing out of proportion?
Well, that is the multi-billion-dollar question. The report claims that if you accept potentials as the real engine, and force fields is just the exhaust, you could build something called a scalar interferometer.
And that's a device that crosses two invisible scalar beams, right?
Yes, you cross them at a distance to create this interference zone.
So the energy doesn't travel through the space between the transmitter and the target, it just emerges there.
Right, because the energy is transformed into space-time stress and then just reappears at the destination. By slightly shifting the phase of those intersecting beams, you literally create a source or a sink in the vacuum.
Oh, wow. So a sink would create what the report calls a cold explosion.
Exactly.
Okay, so you can actually, basically intersect longitudinal waves causes at the interference zones actual extraction, or you're adding energy, removing energy. So that's, again, it's kind of like, imagine, again, temperature, for example, based on the rate of vibration of particles. Imagine you were able to just slow down everything. It's like kind of like slow down time itself. Like, so everyone just gets colder. You're just slow, as opposed to actually taking, as opposed to actually getting something to, as opposed to giving it time to diffuse out through the space. It's literally just like slows down the time. and space. Anyways, it's pretty fascinating. Okay, Joey Rowley says, wow, let's go.
Like you suck the heat out of a region, forcing the local energy to rush inward and vanish. That leaves behind sudden anomalous ice clouds and, well, a giant mushroom-shaped vacuum.
Just like the incident off Japan. And Bearden also connects this to, I think, 77 plumes detected in the Soviet Arctic since the 70s.
He does, yeah. And strategically, why wouldn't a military prefer a cold explosion?
Right, because there's no radiation. But wait, if these beams produce no force fields during transit, are they just completely invisible to our current sensors? Like radar wouldn't see them.
They'd be totally invisible to standard radar. The source material actually describes a sensitive scalar wave detector needed to even see this stuff.
How does that even work?
Okay, and here's another part. Yeah, I just thought of it now. Because on 9/11, right, the towers turned to dust. They weren't turned to dust from like standard lasers and all the stuff, or microwaves, like masers and whatnot. Though, because those ones can be detected with radar and so on. So this is literally using, like, literally advanced mumbo jumbos here, yeah, basically using the scalar setups there where nothing's being detected. And I'm pretty sure this is it again. Inside info. Thomas Bearden was told about Dr. Judy Wood's book and said, yeah, she hit the nail on the head there.
It requires a 40,000 Gauss magnetic pole and a Faraday shield to basically strip away all the normal electromagnetic waves.
Yeah. So this is a key part here. The Faraday shield. Also Thomas Bearden mentioned that many times. And again, as I've alluded to before, I'll play this right here. Faraday. So like I have a Faraday cage I'm making for my Tesla experiments. And then Faraday. Let's go here, adding the chicken wire. So I made a basically chicken wire around this pet fence thingy. So basically, like you can strip off all any incoming or outgoing magnetic fields and electric and magnetic fields. But then you'll still have an empty space of like scalar potential. So again, that's something to think about. It's like basically you're creating a zone where it's not empty. It's like now you have some coherent coherent ocean space, whatever this guy's calling. So let's play it back, and I'm gonna go back here. Go back to this setup. You guys play this again? Okay.
Leaving only the scalar waves behind.
That is wild. And Bearden...
Yeah. So basically, when you remove all the electromagnetic waves, you're just gonna get scalar setups there. So then you can do a bunch of stuff with that. Let's go back here.
Strip away all the normal electromagnetic waves, leaving only the scalar waves behind.
That is wild. And Bearden claims you can even shape this energy, right? Using something called truncated Fourier expansion.
Yeah, it is basically like a 3D printer for force. By layering different frequencies, the report says you can build solid geometric shapes of energy, like glowing hemispheric domes.
The Tesla shields. Witnesses reported seeing those lurid domes over the Hindu Kush Mountains and the Caribbean. And it goes even further into weather engineering.
Right, setting up an
Okay, yeah, so that's Tesla Dome. Basically, you can create solid geometric shapes of energy. Because you can have this entire zone of scalar interference patterns. And you can literally have a Tesla, basically Tesla shield to prevent any electromagnetic radiation coming in or whatnot. Or weapons and so on, or physical matter. So pretty
interference grid over North America.
And again, this part is interesting. Witnesses reported actually seeing these giant domes over Hindu Kush Mountains. Like, what's going on? Just think about imagine the military testing being done on the Earth as we speak.
Use hotspots to create pressure peaks and cold spots to move massive air masses around like chess pieces.
The report points to those...
We go back here. This is okay. Yeah, so you can use this. You can create pressure peaks using it, and then cold spots move massive. But yeah, basically you can do weather manipulation and so on.
Grid over North America. Use hotspots to create pressure peaks and cold spots to move massive air masses around like chess pieces.
The report points to those giant radials, those weird cloud patterns shaped like wagon wheels over Huntsville, Alabama, as actual signatures of this grid. So we have moved from a tiny quantum quirk to literally global scale engineering.
And again, 9/11 had that giant hurricane. So it's like everything is 9/11 is everywhere. And they're talking about weather control using scalar electromagnetics. Again, Thomas Bearden talking about 1984. This report released by the CIA in 2003, and afterward 9/11 pretty much has all of this and even mentions New York City in it.
Which brings us to a really chilling point from the report. In 1982, a Soviet representative actually suggested the world would soon see non-verifiable weapons.
And that is the real takeaway here. We are impartially looking at Bearden's claims today, but it leaves you with such a heavy thought. If a nation can extract energy with no radioactive residue, using beams completely undetectable by normal radar, how would anyone even know they were under attack until the world had already changed? Something to mull over next time you look up and see a strange cloud in the sky.
Literally 9/11, unbelievable. And if you go again, New York is let's go city. I think a new city. I think city. Where in the world is the New York City part? It probably doesn't have the proper setup. There it is. Oh, New York City, yeah, because it's using image to text, so they use the AI or whatnot to convert it. So the megatons. This is on page 19. Let's go to page 19. Yeah, I don't know why it's not searching it up. Okay, page 19. So this is the New York City here. Yeah, this is your New York City. So I want to copy this. What is it actually searching it up as? Oh, it doesn't even copy. Yeah, it should find it. I don't know why it's not finding it. Like, where in the world is it? Oh, there it is. Okay, it finally gets it. I typed New York, didn't show anything. Yeah, so it literally talks about. Yeah, so like what civilian leaders would not even know what happened on them, and yeah, in particular, if monstrous cold explosions appeared without warning in densely populated regions of the U.S., and they talk about note that a massive electrical fireball, like the first two ones, well, yeah, like the impact explosions, say several megatons over New York City would give all the desirable effects of a nuclear weapon without any of the undesirable effects. So again, I think they use the this electrical fireball for the explosions, like the quote plane explosions, and then the other ones was you have literally extracting energy and turning entire city blocks to dust, and we will see that continue more. So now I have other videos in here. So the videos, one is AI overview, Bearden 9/11. So now we'll look at Bearden and his connection to 9. Well, just a video shows him and then shows 9/11.
Bearden.
This is actually from a CNN report he was on in like the 80s, and he's talking about a cold explosion right here. Actually, before we get to that, I want to get to some of the images right here. I'm gonna close this. Yeah, so he talks about this setup here. You can yeah, these are the this is for weather control and so on. And I think he illustrated some other zones of the cold explosions and so on. Again, he has a whole bunch of setups here. I want to see the cold explosion setup here. Yeah, this is the apparently this is what people were seeing. The Tesla shield, courtesy of Hal Crawford. Continue on. And he illustrates some other of the stuff that people were seeing. Tehran, Iran, June 17, 1966. This is pretty well. Tesla ABM defense. So basically, he had a big giant fireball there, seen by 2 aircraft. Observed 4 to 5 minutes. He had a big giant ball there over Iran. It's like, just watch this. Just read this document. It's actually fascinating. There's so much in it. Okay. Anyways, and then he had the other interference setups here. I want to continue. I think he had the famous one, the famous scalar interferometer one. Or you can interfere 2 zones and you have different explosions. Yeah, CNN report on RF weapons 1985. Yeah, that was amazing. I'm gonna continue on. Where did that thing go? He had the one I used before. That image there of the interference and explosion. Yeah, okay, this is airborne radar jammer. The one I used yeah, this is the famous one. I had this before. So you have 2 scalar ones you can interfere and you can have cold explosions and so on. And here's a drawing there, Hal Crawford. All right, let's go back here. Let's play this again. This is from CNN report on RF weapons, radio frequency weapons in 1985. And that's in 1985, and that's way more advanced than you see stuff now on the television. So what happened there?
Believes that these satellite photographs are of mysterious non-nuclear explosions near an uninhabited island in the East Siberian Sea, and that they are discharges from an RF weapon that uses intersecting energy beams called scalars.
In doing so, you can create, for example, either an electromagnetic explosion at a distance, or you can create an electromagnetic implosion at a distance, the extraction of energy from a distant point. This would look like a cold explosion, so to speak. Or you can create an electromagnetic implosion at a distance, the extraction of energy from a distant point. This would look like a cold explosion, so to speak. This would look like a cold explosion, so to speak.
Yeah, and again, you have a whole tower from dust with very little noise, very little sound. Again, even building 7 was being extracted the dust out of it, like the building contents were turned to dust from within for hours and hours and hours, and then it falls quietly after it basically didn't have any energy left to hold it. And now here's him talking about the Hutchison effect, and then we'll also show Martin Fleischmann talking about the importance of the Aharonov-Bohm effect.
Some of the work of the lone inventor, John Hutchison.
I'll make this a normal speed. Okay.
Vancouver, Canada. Some of the work of the lone inventor, John Hutchison, Canada, Vancouver, Canada. Hutchison takes 2 Tesla coils and essentially puts in the center of them a target, which every target has certain nonlinearities, and then blasts away with these 2 coils at them. Basically, what he establishes is an electromagnetic fighting itself, electromagnetic forces fighting themselves. And gravitational force is made when a gravitational potential is made when electromagnetic forces fight themselves to a draw. When, in other words, the gradients become 0. The gradient vectors or the resultants become 0, but the 2 forces are still in there slugging it out. All the energy is still going. The work is still going, but it's trapped locally. That's internal energy. That's what gravity is. And the Whittaker paper tells very well how to do that. So when John got things just right, he didn't have control of it, absolute control, but he bored in there with persistence. And when he got things just right to get the forces to fight to a draw, and there was the right nonlinearity in the target, he would have levitation of things even 64 pounds. He would also, another thing you do with such a thing is you cause the magnetostatic potential to change a vacuum. In other words, that's pole, an unfortunate name in magnetism. But in other words, it causes deposits of monopoles inside materials such as metals. And you'll literally have the monopoles repel each other, and you'll have the explosive separation of metals into all kind of grains and structures according to the waves in the Tesla coils that you're bombarding it with. And so he produced magnificent breaks, Hutchison did, in metals and splits as if it were Venetian blinds. And another thing it does, since this stuff comes from the nucleus out, it doesn't go through the electron shells. Its medium is the nuclei. What you have then is you have changes in the atomic nuclei, which result in lattice changes. You have the production of alloys, which cannot be made in this world with normal processes. And some of those alloys appeared in John Hutchison's work as a result of that kind of bombardment. Another thing you have is once charged with scalar radiation, the nuclei then continue to discharge over a long period of time. And so the material continues to change, alloy form and so forth, over a period of even a year. And you had those changes occur in his work also.
That's actually fascinating again. So interesting, he called it a gravity potential. So, you know, the scalar vector potentials, basically when you have magnetic fields fighting to a draw, you have a zone of 0 magnetic and electric field, and he's calling that gravity potential. Basically, and again, with Hutchison effect, he's theorizing that is what's happening. When you're bombarding it out, the zones where there's 0, that's the gravity mumbo jumbo. And it works through the nuclei, and then that's why you have like basically transmutation and just alloy changes. And he says that it continues on for many long periods of time. And again, Hutchison effect does that. Also 9/11. Again, everything is 9/11. Okay, creator of the patent, Charles Chase. Okay, anyways, that's interesting. Unilab LLC. Okay, I'm gonna go to that. I'm gonna add this link. This is the link to I'll put this on the Hive. Oh, whoops. Why? That's what I hate about YouTube. And like, it's like I want to copy this link, and it has so much tracking info. It's ridiculous. And then it finally gets to it. So that link is actually. So there's the link. Okay, that's it. Oh yeah, I'll put these in there. This is the full report, and then yeah, this is the full report, the Siena report that now the versions post on Rumble. And I want to see that. Go back to that patent actually. You said Charles Chase, Lancaster Unilab LLC is the website for the creator of the patent. So Charles Chase, Unilab LLC. I just want to check his website quickly. So that's Charles Chase. Unilab LLC. Secretmilitarytechnology.com. Okay, what? Yes, it's literally a website. Founder of Unilab, former Skunkworks project manager. You go to secretmilitarytechnology.com. I think these guys made this with Claude AI, maybe. Okay, former manager, revolutionary technology programs, Lockheed Martin. Holy, this guy's pretty big setup there. Unilab LLC. Okay, Unilab, this is this website. Coherent matter wave. Oh, now he has an HD setup set. Okay, this is way better than the patent setup. Coherent matter wave. Okay, now this is amazing. I'm gonna archive this. This is a fascinating find. Thank you, Void is in whatever is the longest name ever. Thank you, Void. All right, I'm gonna archive this on a Hive blockchain. Coherent matter wave, and it has images too. This is amazing. Okay, so we got this stuff. Coherent matter waves for atomic manufacturing. I'm gonna just paste these in here. This is just okay, and then. This is actually ridiculous. Oops, I archived there. Okay, this is another image. I'm gonna paste this into here, and then paste it into here, and then save this. This is okay, this is Lockheed Martin guy. Holy. Unilab. Yeah, I like how he has actual quality images instead of that patent black and white. All right, so that is this guy here on another level. UN Advanced Propulsion Energy at MIT. Now we got this guy's wild. Co-inventor of the patent, Moses Joseph Arman, PhD, was an Iranian-American physicist, researcher, inventor who was known for advancing frontiers of elementary particle physics and nukes. Okay, yeah, this is these guys are a pretty big setup here. Holy, yeah. So they definitely have donations. What in the world's going on here? These guys are working for Lockheed Martin. It's like you're working for Lockheed Martin. If you look at the stock price, it's like Lockheed or anyone working for Lockheed Martin, they don't need donations. So Lockheed Martin, basically, I noticed this. Whenever the price goes up, war's going to start. A war was starting. Actually, stated this even before the Iran war. It was going up and up. So here's stock market price of the stock price of Lockheed Martin. So it did it, basically 10x since in 2010. So again, as war goes up, a lot of money is being made. All right, let's continue further here. Oh yeah, so and then the last one here. So we got that. Now we have, this is Martin Fleischmann. Listen to Martin Fleischmann talking about the Aharonov-Bohm effect. And I got this from Bob Greener. Bob Greener uploaded this. It was great that he found this clip here. In 1981, Arman joined the Air Force Research Laboratory AFRP to lead the High Power Microwave Directed Energy Directorate. Holy, okay, these are huge names.
Now, we are at a watershed, and there are some people who have a sort of connection with funding agencies present in this room. I think the rejigging of the Bohm-Aharonov effect
So notice Bohm
is long overdue. I think that it's going to be one of the most fruitful areas of research in the next century. Now, we are...
He literally said it's overdue that they gotta, basically, and also mentioned the guys' funding agencies, but he says they need to rejig or basically re-examine the Bohm-Aharonov effect, and he says it's long overdue that they've got to actually look at it seriously, and it's going to be the most fruitful science research in the next century.
Overdue. I think that it's going to be one of the most fruitful areas of research in the next century. Now
so it's like he obviously knows what's going on. So that's Bohm-Aharonov effect, and I got this from here. Yeah, so I got it from Bob Greener. Bob Greener shared some fascinating Q&A clip from Martin Fleischmann regarding connecting classical and quantum mechanics. Here's the other one. And then as the key to cold fusion, as well as stating the importance of the Aharonov-Bohm effect. The Aharonov-Bohm effect involves the change of phase of a beam of charged particles, typically electrons, around a solenoid whose magnetic field is fully contained with it. So in other words, so basically you have a solenoid, it has a magnetic field completely entrapped like a Faraday cage, and then anything near it is still going to be affected by it. So that's, let's play this here as well. This one is essentially talking about the ether, connecting classical and quantum mechanics.
So I think we are at a very interesting watershed. I think you probably agree. We can see Easy ways to implement the research, difficult ways to implement the research. Well, of course, this is not the end of the story. Let me just close the loop. There are all sorts of other phenomena which we really can only interpret in terms of quantum field theory. And then there is this enormous question of, if we think about condensed matter physics and chemistry, biology even, in terms of quantum field theory, then is there a link between classical mechanics and quantum field theory? I've been waiting very patiently for someone to speak about that, because I know the information about parts of the subject exist, but I observe that people are extremely reluctant to say anything about this at all. Thank you.
All right.
So
he says that basically there is a connection with classical and quantum mechanics. Yet he knows people they're all just scared of talking about it, reluctant to say anything about anything at all. Again, my view is just when you connect the two, it's basically cold fusion is just a obviously arrives from it. All right, I'm gonna paste this also in here, so we have all the links set up. Alrighty, and go back to this setup. All right, and now, yeah, this one I already played. Now this is the image from a video here from this is the Wikipedia. I got this image from here. This is from the mainstream physics science guy. Oh no, not this one. This one here. Okay, this is a YouTube channel from Veritasium.
The magnetic field could be.
So this is Big John. When again 3 months ago, the tiny donut that proved we still don't understand magnetism. And I'll illustrate this. And now we're gonna actually look at the Aharonov-Bohm effect in detail, just try to make sense of what this all is. Because when Veritasium is talking about it, it's definitely big, as these guys again, biggest gatekeepers, but also biggest just mainstream science channel on YouTube. And but nonetheless, they do give you a lot of good mainstream info. But outside, yeah, but then they obviously cover up some aspects of gyroscopes, for example. I cannot believe how they cover up gyroscopes and nobody's like seeing how like ridiculous these guys are. But anyways, but nonetheless, this is pretty interesting setup here. And so anyways, now we're gonna go to the Bohm. Oh yeah, this was on this thingy. Okay, I'm gonna archive this. Okay, publish blockchain. Aharonov-Bohm effect. Okay, there it is. Let's go back to the Aharonov-Bohm effect. All right. Okay, chat. Yeah, it was disconnected. The Aharonov-Bohm effect, sometimes called the Actually, what I'm gonna do is I'm gonna turn on my Wi-Fi so that it doesn't happen again. Okay, Wi-Fi is on. So Aharon-Bohm effect, sometimes called the Aharonov-Bohm effect. It's a quantum mechanical phenomenon in which an electrically charged particle is affected by an electromagnetic potential. What in the world? It's like you always think you know electromagnetism, and all of a sudden they just throw some random thing there. Despite being confined to a region in which both the magnetic field and electric field are zero, the underlying mechanism is the coupling of the electromagnetic potential with the complex phase of the charged particle's wave function. Okay, so now you have a charged particle has a wave function, and the complex phase of it, basically you basically have the phase using a complex number, mumbo jumbos, is accordingly illustrated by interference experiments. All right. So basically, you got, yeah, this is the part where we got to wrap our heads around. So it's affected by, essentially, if you do an experiment, what you have is, let's say you have here's a Aharonov-Bohm effect apparatus showing barrier. X is the barrier. And then slots 1 and 2 electron paths, so you would send electrons through it. And magnetic whisker is, difference pattern is the I. Magnetic flux density is, no, that's I. Interference pattern is a P. B is pointing out of figure is the magnetic field. You basically have a magnetic field all contained within here. And magnetic vector potential A. So the A is here. So basically, you have magnetic field pointing upwards and it's only within this confined space. But then this is the scalar potential as around it, where it has a zero magnetic or electrical potential. Yet these are still affected. So electrons are still affected by these scalars. So that's basically, yeah, you have a Faraday, you have a magnetic field inside a Faraday cage. In some experiments, the whisker is replaced by a solenoid. So instead of a whisker, Yeah, solid, basically an actual yeah, basically an actual loop of coil. The electrons in path 1 are phase shifted with respect to the electrons in path 2 by the vector potential, even though the flux density is nil. So these electrons coming in, notice this one comes in a bit faster than this one. So these are shifted based on literally going, just because there's there's magnetic field contained within here, even though there's 0 detected outside. The Unilab is also a YouTube channel. Okay, so we gotta go to Unilab. Okay, we're on another level. This guy's on another level, Unilab. And I thought I posted that. Oh, I didn't. Okay, there's the Unilab. I'm gonna subscribe to this guy. Help to the Philippines. Unilab. Okay. Oh, they have Wolfram Alpha in here too. Unilab Advanced Propulsion and Energy. That's Wolfram Alpha. Well, these are huge names here. So Stephen Wolfram, he's the guy who's the Wolfram Alpha guy. So that's his website. You can literally ask it anything. Anything math related. This was like one of the first AI before AI became famous. So that's actually quite wild. You can actually calculate what you want to calculate. For example, solve x. Yeah, in this equation, solve x. Yeah. Let's do that. Yeah, let's do that. That's Charles Chase. No, this is Wolfram Alpha. This is Stephen Wolfram. This guy's Stephen Wolfram. That's not Charlie Chase. This is he might be the channel's Charlie Chase, but this guy here is Wolfram Alpha that he's on it. So he has a guy that's massive on there. This guy here. It's pretty cool. You can solve the graphs. This is one of the first actual AI. They use like AI to solve math with a huge big language models on. So that's Wolfram Alpha. So that's actually I'm gonna upload this here. Unilab. Yeah. So he has a channel, but this is the setup here. Click this. Yeah, but Wolfram Alpha is the big name there. There's Wolfram Alpha. I'm just gonna post everything in Wolfram Alpha. Wolfram Alpha, and then the other one I forgot to do it on there. So again, with the cool thing with the Hive blockchain, it's like you can access it with anywhere in the world. No KYC. Like you don't need to log in with digital IDs. Aharonov-Bohm effect. Coherent matter wave. Where's that other Unilab? Unilab. I thought I did it there. Unilab. Coherent matter waves. Charles Chase is the director of Unilab. It's way bigger than deal than Wolfram. Talking about yeah, he's a bigger deal, yeah, but not publicly. Publicly, the bigger name is Wolfram Alpha. Wolfram is literally much more famous. Like I knew about Wolfram Alpha like 20 years ago. I had never heard about Charlie Chase. Decoherence and okay, I'm gonna archive. I thought I did archive this. Let's archive this again. View. Oh, okay. It's already archived. It says. Oh, so I did post it. I don't know why. Why did it not show it then? Why is it not showing on the archive? So that's cool. So when I archive again, oh, that's coherent matter wave. So that's this one here. That's a website. Oh yeah, no, yeah. I wanted to copy this in here. That's what I wanted to do. That's what I wanted to do. Yeah, I guess it was already archived. Okay, and that's pretty cool. You are archived and it tells you it's already archived. So hashes match, content unchanged. So it literally tells me content was unchanged because basically the hash mathematical magic. Okay, so now we're doing that part. Let's continue on this electromagnetic setup here. So the whole idea is if you have magnetic field in here, and then you essentially put in a Faraday cage, and it still affects the phase of it. So this electron gets slightly slower or faster depending on which side you're on. There, and see some other stuff. That's actually this is actually pretty good analogy there. I mean the explanation. But then they say whisker. I don't know why they say whisker. What in the world's a whisker? Yeah, I'm gonna start sitting. Okay, I'm gonna close this. Okay, I'm gonna close this setups here. Yeah, I'm gonna play some of that video clips soon. So again, uses scalar potentials is is basically the theory behind what this is, but this is a physical phenomenon. If you have no magnetic field, it still gets affected by it. So in other words, the actual space is being longitudinally affected by possibly. So that's again, this is actually. I hate when I right click it. This shows up download image file. Like, why did they do that? Okay, paste this there, and then oops, paste this there. No, I don't want to copy this. I want to copy this. Electromagnetic Bohm effect. Okay, so that's wiki. Okay, send, and okay, so now we got that part out of the way. And now, yeah, the most commonly described case, sometimes called the Aharonov-Bohm solenoid effect, takes place when a wave function of a charged particle passing around a long solenoid. So this is basically a solenoid. You have just a loop of wire. It's a type of electromagnet formed by a heliac wire. Metal boosters are thin wire-like structures that form from a metallic surface without any specific external trigger. Interesting. All right. So solenoid is a type of electromagnet formed by heliac. So basically, you have a coil like this, and it creates a magnetic field when you pass current through it. Which generates a controlled magnetic field. The coil can produce a uniform magnetic field in a volume of space when electric current is passed through it. All right. So that's a solenoid. All right. I'm just gonna archive everything I see on the Hive blockchain just because like it just feeds the AI. So basically, anyone could use this data for free with no API access. Just do that. And it's there for anyways. The coil can produce a uniform magnetic field in a volume of space when electric current is passed through it. And this was Andre Marie Ampere coined the term solenoid in he's an Ampere guy. 1823, having conceived of the device in 1820. All right, so we got this guy right here. So now, when the wave function of a charged particle passing around a solenoid experiences a phase shift as a result of the enclosed magnetic field, despite the magnetic field being negligible in the region through which the particle passes, and the particle's wave function being negligible inside the solenoid. And the particle's wave function being basically, it's literally completely like separate from it. It just doesn't. This phase shift has been observed experimentally. There are also magnetic Aharonov-Bohm effects on bound energies and scattering cross sections, but these cases have not been experimentally tested. An electric Aharonov-Bohm phenomenon was also predicted, in which a charged particle is affected by regions with different electrical potentials but zero electrical field. So yeah, so that was the magnetic one. Now you have an electric Aharonov-Bohm effect phenomenon was also predicted, in which but these ones, they're also magnetic. No, there are also I'm gonna read this again. So this was experimentally observed. There are also magnetic Aharonov-Bohm effects on bound regions, bound energies, and scattering cross sections, but these cases have not been experimentally tested. An electric Aharonov-Bohm effect phenomenon was also predicted, in which a charged particle is affected by regions with different electrical potentials but zero electrical fields. But this has no experimental confirmation yet. Okay, so they're assuming that same for electrical. A separate molecular Aharonov-Bohm effect was proposed for a nuclear motion in multiple connected regions, but this has also been argued to be a different kind of geometric phase, as it is neither non-local nor topological, depending on only local quantities along the nuclear path. The optics guy did it with light too. Okay, so we have Bill's in here. All right. Yeah, Bill, I have you blocked on Twitter because of the thermite nonsense. Please retract your thermite stuff. But anyways, you're fine here for now. Charles Schmitz is the director, is way bigger. Well, no, he's not. He's not a bigger name. It's like nobody knows who Charles Schmitz is. But yeah, he could be bigger, obviously, in the Illuminati social ranking. The global directed energy weapon market project to reach 27. Okay, pretty interesting. Navy's visions for a laser-equipped fleet and the Army's race to field EHAL. Okay, anyways, there's a bunch of directed energy weapons, moment jumps. So here is the Aharonov guy. He's got a huge pipe, just like John Hutchison. Holy yeah, but he's got this checkered chest floor there with Freemasonic imagery there. That's pretty interesting. All right. Yakir Aharonov, I'm assuming he's from Israel. Yeah, so he's from Professor Emeritus Tel Aviv. He's still alive. He's 93 years old. Okay, so it's Tel Aviv 2 vector state. I guess pretty. Oh, he's got a giant dice there. Okay. And then where's the other guy? Aharon-Bohm effect. Where's the Bohm? Yeah, Doctor. Oh, his advisor was Bohm. This is this guy here. So he died in 1992. And he's born on December 20th. Interesting. Weak measurements of negative time. Yeah. So anyways, it's like they do all these other stuff. while the direct energy weapon setup is huge. Dove it, yeah, past 1992. That's pretty interesting. All right, so that's okay. So this is the Aharonov-Bohm effect, solenoid. Okay, now, so we have that part. I generally understand. Basically, yeah, it pretty much makes sense. But I'm gonna listen to this setup right here.
Below the strange, but
Okay, we'll go back here. Then scalar potentials I might have to do for another day there. Just like what in the world? They explain it away with scalar potentials. Yeah, Basil J. Hiley was Bohm's collaborator. I corresponded with Hiley several times from 2019 2023. Interesting. Oh yeah, you're deep in this. That's epic stuff. Kurt Megal is the best interview with Aharonov. Okay, I'm gonna play this right here.
Such a setup, if trick or so you lose this specificity when you go from a potential to an electric field, and Aharonov wasn't comfortable with that. So he thought, what if every quantum system was actually influenced by the potential and not by the field?
right.
Okay, so I'm gonna just sit down 1 second. Oh, been standing for an hour and a half on it. So anyways, pro tip: just stand a lot already. Sit down, and then I'll play this. So I'll play this right here.
So it's the potential that shows up in the Schrodinger equation. So it is what influences wave functions. He had to find a way to prove that what we're observing is always because of a potential and not because of the field.
How do you do that?
Complicated.
See, Aharonov had to design an experiment that would send a particle through a region where there's no electric or magnetic field, but there is a potential. In such a setup, if the phase of the particle's wave function started changing slower or faster, that had to be the direct result of the potential itself, because there are no fields.
But that's where you run into a problem, because there's no way to directly measure the phase of a particle's wave function. So how do you devise an experiment that can yield a measurable result? Well, Aharonov enlisted the help of his mentor Bohm, and together they came up with the following theoretical experiment. It starts with a beam of electrons, which is split into two. In the middle of these two beams is a tightly coiled wire known as a solenoid.
Okay, so there's that setup over here. Where's that? Yeah, basically that's a solenoid you have there, and you're gonna have a beam of electrons. Fire. This was a different setup, but going around it like that way. This one is the one on Wikipedia has it basically going like split, going inwards towards this setup here. Or I think no, this is just the path there. Yeah, basically interference pattern. Basically you have it slits there, electrons going in, but it's a similar idea. Let's play it here.
Now, solenoids have an interesting property. When you run a current through one, it produces a strong magnetic field inside the coil and a very weak field outside the coil.
Okay, so it's basically a strong field inside and weak. It's super weak outside, and apparently it's too weak to change the actual phase of the electrons. So
the longer the solenoid, the weaker the field in the surrounding space. For simplicity, Aharonov and Bohm imagined a setup with an ideal, infinitely long...
Okay, so they basically made a super long one. So that's the whole idea. Where's the solenoid setup here? So basically they made a super long one so that there's very little like field coming out of it.
Solenoid, one where the magnetic field outside the coil is exactly zero. After traveling on opposite sides of the solenoid, the electron beams are redirected back towards each other by the researchers. And here, at this point, they intersect. Now, since electrons behave as waves, the waves from the intersecting beams overlap.
Imagine you project a double slit at the wall. Now imagine you put this coil in the way so you can see the shadow. Anyways, over the pattern. Yeah, anyway, so they're not intersecting right here.
Since electrons behave as waves, the waves from the intersecting beams overlap and produce an interference pattern, bright fringes with gaps in between them. The exact pattern depends on the phase of each of these waves. When the solenoid is off, there is no magnetic field in the region the electrons are traveling through, and there is no magnetic potential. The phase of the electrons changes in the same way across both beams, regardless of whether they pass above or below the solenoid.
Okay, so this is when the solenoid is off. Basically, it just behaves just the exact same.
And so you get an interference pattern that
pattern looks just like that.
Like this.
Okay.
But when the solenoid is turned on, well, there is still no magnetic field because it's confined entirely within the coil, but there is a magnetic potential. That may sound strange, but remember, the magnetic field is the curl of the magnetic potential.
Yeah, so no, this is another part. So magnetic field is the curl, basically like the rotation of the scalar potential. So in other words, it's a derivative of a object behind it, and this is essentially what these are. This is like this cross product. I'll have a quick look at the equations right now because I did the quantum mechanics video on the spherical harmonics, and I actually have a general understanding of what these are. So we'll have a look at that in a bit. But anyway, so basically it has a scalar potential, and the magnetic field is a derivative of them. It's like derived from that. Essentially, just think of that way. It's an quantity that's derived from it.
The curl of the potential can be
It's
zero.
a two-way derivative as explains. Yeah. I'll go over the thingy there. Yeah, this Bessel J Wiley. Yeah, no, I just say derivative, not in terms of the mathematical derivative, but what I mean is derived from the scalar potential. So it's not like so magnetic field is not a. It's like a wave. Yeah, it's like the actual wave in an ocean.
Magnetic field is the curl of the magnetic potential. The curl of the potential can be zero in some region, even when the potential itself is not. And that's exactly what's happening here.
Okay,
Now,
so basically the magnetic field can be zero, even if the scalar potential is not zero.
that may sound strange, but remember, the magnetic field is the curl of the magnetic potential. The curl of the potential can be zero in some region, even when the potential itself is not. And that's exactly what's happening here. Now, take a closer look at the vector potential.
Yeah, I'll have to wrap my head. Okay, Bill says you did a good job on your spherical harmonics. So yeah, epic stuff. Thank you. It's not a scalar potential, the quantum potential as precognitive active information that is asymmetric or non-commutative. All right, epic stuff. Let me know when you have your spaceship design. Oh, got it.
In the space the upper beam passes through, the potential points in the opposite direction as the beam. So here, the phase changes faster. But below the
But
solenoid,
notice here, they're actually having a rotation set up here.
it points in the same direction as the beam. So the phase changes slower. If the phase truly
Wait. So phase changes if it's opposite there. So in other words, is there actually an ether rotating or something?
potential. In the space, look, take a closer look at the vector potential. In the space the upper beam passes through, the potential points in the opposite direction as the beam. So here, the phase changes faster. But below the solenoid, it points in the same direction as the beam. So the phase changes slower. If the phase truly depends on the potential alone and not the field, then the phases of the two beams should evolve differently. So as a result, the interference pattern should shift when the solenoid is on versus when it's off.
The magnetic
Yeah, so basically it's shifted slightly. So how the interference pattern, shifted because it's slightly, like basically it's like delayed.
field could be just zero, and yet the presence of some vector potential could actually lead to observable effects. That wasn't supposed to happen, right?
What I love about this story is that it reminds me that individual people can challenge.
All right, no, that is I'm gonna save this now. When did I put the thingy? I have a link of this. Okay, there's the Aharonov-Bohm fact. Okay, this is the time stamp, and I'll do is I'll summarize using AI. All right, so that's pretty interesting setup there. Yeah, I think we pretty much have it. Now the whole idea is what in the world is a scalar potential? But I'm gonna go back here, magnetic field. Like I'm gonna go back to this equation he says. Actually, I'll use the wiki first because I like reading from the wiki because it's it gives you the full mainstream and like it details the mainstream narrative of magnetic field. Curl of vector potential. The wiki. Just see what the equations were and then wrap our heads around that. Magnetic vector potential. You gotta make sure to look at the picture Veritasium shows. Which photo? This one? Or which one are we talking about? Can quantum mechanics solve the hard problem of consciousness? Yeah, again, consciousness, whatever. It's like, I want a UFO, okay? Can consciousness solve the problem of UFO I want? Okay, so this is the curl. Wiki doesn't know this stuff yet. They have no commutative, non-commutative wiki page, for example, the science. No, I know wiki. I'm talking about the mainstream narrative. What I also want to do is I want to understand the mainstream narrative and then see how the alt info lines up with it. So this is the curl of the magnetic field. I'm gonna actually ask it right now. Equals this, and then basically this is just saying that this equals to x. I'm just gonna do this right here. we're gonna tell Grok right here quickly. They get a printed out image of the actual experiment. Yeah, we'll get to that in a bit. I just want to get this. Explain what this equation means. Give me definitions and equations of each term. It's the magnetic field being a curl of the vector potential. It's like, again, I saw TR3B so close I could have hit it with a rocket that has a large red center and emits a low humming noise. You actually saw one. You have a photo. Okay, and so while it's running, let's go back to this. You said they did the experiment actually. Where's the experiment? Yeah, this is just a bunch of ads right now. Yeah, I know, but this is the thing. It's like they can test it out anytime.
Is physically impossible. So instead, Chambers used a
Okay, you have 1987. Okay, oh, you have photo. Okay, please send me a photo plus more info at contact at MES.fm. Because just that's the email. I'll put it like this. I think it should be fine. Just send out if you have it. The military definitely researches super. I'm gonna place it right here.
a tiny needle-like piece of iron, about a millionth of a meter.
Let's go back.
Colleague of Aharonov-Bohm's at. Ultimately, there was only one way to settle the debate. Someone had to actually do the experiment. The first to try was a colleague of Aharonov-Bohm's at the University of Bristol, Robert Chambers. Chambers' experiment largely followed the setup Aharonov-Bohm proposed, with one notable exception. An ideal solenoid would have to be infinitely long, which is physically impossible. So instead, Chambers used a tiny needle-like piece of iron, about a millionth of a meter thick.
So that's what I meant by whisker, just like super tiny one.
And 500 times as long. When this iron whisker was magnetized, it produced a magnetic field.
Okay, so it's literally just a tiny whisker. Like literally just a tiny. Literally, it is a whisker iron, a magnetic iron. Go back.
Times as long. When this iron whisker was magnetized, it produced a magnetic field that was strong within the metal itself, but negligible outside of it, as well as a magnetic potential in the surrounding region of space. To get a baseline interference pattern, Chambers fired two beams of electrons around an empty region of space. Then he added the magnetic whisker. When he fired the beams again, the interference pattern shifted. It seemed that Aharonov and Bohm were right. But critics were unconvinced.
People objected to it because since the whisker is finite, there is always some magnetic field that will go out.
Maybe a stray field was responsible for the effect, not the potential.
And that's throwing no shade on their colleague who did these cool experiments. It's like, it's hard, right? It's really hard.
And so it went for several decades. Experimentalists repeatedly tested the Aharonov-Bohm effect, but each trial had flaws that left the result open to debate.
Until in 1986, a team of Japanese researchers led by Akira Tonomura came up with a new way to do the experiment. See, they used a tiny donut-shaped magnet to make their magnetic field. With a perfect torus, all the magnetic field is contained within the loop. Outside it, it's absolutely zero. And as an added layer of protection, the team also coated the entire magnet in a layer of superconducting niobium, which would block out any leaking fields. Now, previous experiments relied on turning a magnetic field on or off, but Tonomura's team took on a different approach. In their case, the magnet is always on, but because of its unique shape, the potential outside the torus is different.
And another thing I want to note is that this was verified in 1986 when they actually fully the mainstream agreed on it. The report by Thomas Bearden was in 1984, and he's talking about this as of a scientific fact, not as well as still in a theoretical, not fully accepted yet. So that's again, that drives home the point. The 1984 report is definitely onto something. Okay, and also voices CMI upload over 20 reports of triangle UFOs escorted by accompanied by or followed by U.S. military jets. CR3B is part of this space You see, I wrote about I did an article and I mentioned Edgar Fucci talking about that. But I want to know go to National UFO Center, and I found over dozen. Okay, I want to know which ones you wrote and what's your actual name, because you said void someone, because I want to make a post about it. Anyways, we'll keep doing this.
Different from the one in the center. It points to.
No, the Aharonov-Bohm effect was first published. No, I know it was published, but every one of the experiments, it was still in theoretical setup. It wasn't until this 1986 right here that they made it irrefutable, according to mainstream. No, I'm talking about this right here. That's why this is 1986. It was after the 1984 report. So this other one was still, by mainstream terms, theoretical.
As an added layer of protection, the team also coated the entire magnet in a layer of superconducting niobium, which would block out any leaking fields. Now, previous experiments relied on turning a magnetic field on or off, but Tonomura's team took on a different approach. In their case, the magnet is always on, but because of its unique shape, the potential outside the torus is different from the one in the center. It points towards us on the outside and away from us on the inside. And the team realized they could take advantage of this. Different from the one in the center. It points towards us on the outside and away from us on the inside. And the team realized they could take advantage of this. They started by firing off an electron beam, which was actually wide enough to be treated as two separate beams. Part of it traveled along through empty space and functioned as the control, whereas the other part washed over the entire torus. And what's important here is that the beam is wide enough so that part of it passes around the torus and part of it passes through. Then, at the end, a biprism deflects the electron beams toward each other. They intersect, and this is where they create an interference pattern. Now, think about what this interference pattern should look like. Well, for starters, there should be a shadow of the torus, so we can fill that in. But the rest? Well, it depends on whether the Aharonov-Bohm effect is real or not. If it's not real, we'd expect to see an interference pattern that looks something like this, where the pattern outside the torus and in the center match up. But if it is real, then the electrons that traveled through the center would have experienced a different potential, which would have shifted their pattern by half a phase. So that should look something like this. Now, here are the results from Tonomura's experiment.
You see, these are the interference fringes inside and outside the magnet. And then if you follow what is a peak outside the torus, lines up with a trough inside the middle, and then it's a peak outside again.
And that's exactly what they predicted.
This is exactly what they predicted.
So it's real?
It's real.
Only the Tonomura experiment was really the final proof, experimentally.
And yet, soon a new debate emerged. The effect is real, sure, but how should we interpret it? What is it really telling us about the nature of the universe? Today, physicists largely fall into one of two camps. The first camp claims that potentials aren't just mathematical conveniences.
There's the most beautiful picture ever. Yes, that's a pretty cool image.
They can influence physical reality. This is the perspective initially favored by Aharonov and Bohm. As they wrote in the abstract of their paper, contrary to the conclusions of classical mechanics, there exist effects of potentials on charged particles, even in the region where all fields vanish. Some take this position a step further. Since the potentials show up in the Schrödinger equation and the fields do not, well, they argue that the potentials are more fundamental to physics than fields are. Richard Feynman supported this idea. He wrote, "A is as real as B, realer, whatever that means."
I mean, I kind of like that interpretation, but something about the potential bothers me, and that's the fact that you can set the potential at any arbitrary height. It can be plus infinity, it can be minus infinity, anything in between. So wouldn't that change, how the potential actually influences the wave function?
This bothered me too, so much so that I actually ended up asking a professor about this. But it turns out it can't.
It knows it's not just the potential that's entering the observable, it's the line integral. So it's only A that enters, it's not the magnetic field. B vanishes, it's only A, but it's not A alone.
It gets a little technical here, but if I pull up,
as one does,
as one does, a flip chart, then we can actually run this through. So if you look at how the potential shows up, then what's measurable is not the phase directly, but it's the phase shift. Call it delta theta. Then the phase shift is the line integral of A over the path, or dotted with the path. So you get this. Now you can imagine, okay, let's add a constant to this. And if our setup is roughly We start here, one electron beam goes like this, and the other one goes like this, and these are symmetric. Then the potential here will point, let's say, in this direction, but here it will point in that direction. Let's say instead of A, we do A plus C, some constant. Then when we're taking the path this way, we'll be adding that C, and we'll be dotting it with dx. But because that path is the exact same, when we go this way, we just subtract it. So it cancels out. So the potential, yeah, it does show up, but in such a way that all the arbitrariness of the potential, it cancels out perfectly.
Okay.
It's a geometrical quantity involving A that has taken care of, for which all that residual ambiguity has literally canceled out.
The potentials being physical might sound strange, but the second interpretation is even stranger. Physicists in Camp 2 maintain that potentials really are just mathematical objects, and the fields are responsible for the effect. But in Tonomura's experiment, the magnetic field was completely confined within the solenoid. For this interpretation to be true, its supporters are forced to assert that fields can act non-locally. That is, a field can influence things outside the region of space where the field itself exists. Many physicists find this idea difficult to swallow.
I think the idea of saying that these fields act non-locally undoes the reason why we have field theory. Right? The great triumph of field theory, which has served us so well for more than 100 years, is this stubborn notion that local causes yield only local effects.
And yet, Aharonov's own perspective has shifted from Camp 1 to Camp 2.
When we published the article, we called it the effect of potentials. When you use potential and use the Schrödinger representation, it looks as if everything is local, but it's misleading because those local potentials are really not physical. Later, I decided that it should be called a non-local effect of the electric and magnetic field, the electron field, the effect of a field that is not where it is.
While non-locality remains a controversial idea, a sizable portion of physicists do side with Aharonov, and the debate continues to this day.
I maybe have a third interpretation.
Good.
So right now we're saying either the potentials are real or fields are acting non-locally. But what if there's a third option where the fields are still local and it is the fields that are affecting the change, but rather it's the particles that are exploring all possible paths all at once? You could potentially even have some quantum tunneling effects going inside an area where there are fields. As the electron, or the wave function at least, explores all possible paths, gets influenced by those slight bits where the wave function is inside the field.
I actually don't think that's ridiculous, Casper. That's for a strong ringing endorsement. I think there's a lot to that.
Okay.
If we could think about these things as, it is indeed the quantum phase that's being affected.
Yeah.
We can describe that phase in terms of quantum mechanical path integrals. I think that's a perfectly reasonable way to frame it. So yeah, I'd buy that.
That's awesome. I'm pretty sure this isn't the complete answer, but one thing which would be cool is if someone else takes this idea, or maybe gets inspired by it and they're like, actually, that doesn't work, but here is how it does work. And now we're closer.
That's right. That would be the best possible outcome. Well, the best possible outcome is you're just right. But the second best possible outcome is that nudges the community more broadly to ask new questions of familiar material. That's right.
One new question the community asked was, is there also a gravitational version? In 2022, researchers at Stanford tested this. A simplified version of their experiment works something like this. They shot up ultra-cold rubidium atoms into a tube-shaped vacuum chamber, at the top of which was a tungsten mass. Now, atoms, like electrons, are also governed by a wave function. So they split each rubidium atom's wave function into two distinct packets, and they launched them to different heights. One was sent really high and got close to
back to this experiment. Oh, this is a gravitational Aharonov-Bohm effect. I want to play this again. This is pretty fascinating.
Gravitational version.
The community more broadly to ask new questions of familiar material. That's right.
One new question the community asked was, is there also a gravitational version? In 2022, researchers at Stanford tested this. A simplified version of their experiment works something like this.
They shot up ultra-cold rubidium atoms into a tube-shaped vacuum chamber, at the top of which was a tungsten mass. Now, atoms, like electrons, are also governed by a wavefunction. So they split each rubidium atom's wavefunction into two distinct packets, and they launched them to different heights. One was sent really high and got close to the mass, whereas the other didn't. And then, when the two collided at the bottom, this created an interference pattern.
And when they let this interfere and accounted for all other effects, they could clearly see the phase shift as predicted by Aharonov-Bohm. So it seems like the gravitational Aharonov-Bohm effect is real. If the results hold up to scrutiny, this is a huge finding, because it suggests that the electromagnetic and gravitational potentials can influence reality at the most fundamental scale, even when all the fields are exactly zero. So, does that mean that most physics textbooks are wrong or need updating?
Don't throw out all the textbooks. They're beautiful. We learn a lot, but that doesn't mean we're done. And we should be open to surprise. And just because things haven't changed in, let's say, 200 years, roughly between, say, Lagrange and Aharonov-Bohm, they still could change, right? And they can sometimes change in beautiful and surprising and very powerful ways.
I read somewhere that the reason you decided to do the AB effect was that you didn't really think potentials were something that was just a mathematical tool like most scientists believe.
That is correct. I was very ignorant. Luckily, sometimes it's good not to know too much.
Okay, so it's interesting. So Aharonov now thinks that the potentials aren't real, and that just the electric and magnetic fields can affect things non-locally. That's again, it's like now the question is, what in the world are these electrical relativist vector function from which electromagnetic can be derived? So there's a vector function that can be derived from it combines both electric scalar potential and magnetic vector potential into a single 4 vector. Okay, so something's seriously wrong with magnetic science. I'm gonna go right here. So this is that Grocket finally answered it. Hold on 20 seconds. So the equation right here, curl. This is the that thingy there on top. States this is the magnetic, and this is the vector potential. This is the magnetic field. States that the magnetic field is the curl of the magnetic vector potential A. This is not just a mathematical trick. It is a fundamental. It is a fundamental and always true relation in electromagnetism, both classical and quantum, and it follows directly from one of Maxwell's equations. Why this relation exists? One of Maxwell's equations of Gauss's law for magnetism is V dot B. This states that the magnetic field has no source or sinks and has no magnetic monopoles. Mathematical identity tells us that the divergence of any curl is always 0. All right. A mathematical identity tells us that the divergence of any curl. This is the dot here. So what does this mean? Therefore, we can always write B as the curl. Okay. Anyways, this is a bit more mathematical. I'll have to. Oh, that's del operator. So basically, it's a derivative right here. So this is a curl, measures rotation, circulation of a vector field. So it's actually rotation. It's literally saying it's a rotation of the vector potential. So it's literally the ether rotation. Okay, this is something I'll have to review later. It's a finally making sense of the double split. Okay, I'm gonna quickly just search up your UFO setup here, the guy, and then show you the UFO guy I talked to. I'm gonna go over right here. All right, Grok. Right here, I'm gonna put this on the Grok. All right, and I'm gonna do this. It's a pretty fascinating, so I'm gonna archive this. Okay, and I was gonna do the UFO one, but it's like 2 hours now. Yes, I do want to find this guys quickly. This setup here. So where is your TR the void? Where's your TR3B Mama Jumbos? Where's TR3B 1987? I saw TR3B, a structural link. Did you email me any of the stuff? Go to National UFO Center. I have over a dozen. Okay, but the thing is, what are your actual name? Like, where's your TR3B? Okay, so I'll check my email unless you sent me any. Okay, Proton confirm forwarding request. I got a whole bunch of spam here. All right. All right. Patent release National UFO Center. So what I'm getting is, where's the TR3B set up to ad block detect it? Yeah. Whatever. Okay, TR3B, Manta, Aerospace. Okay, anyways, and the reason I'm showing this up, okay, this is all propulsion, but where's the other one? The UFO, National UFO Center. National UFO Center. National UFO Center? How come it's not showing it? Black Triangle UFO, Black Triangle. I like how it shows up there. But anyways, it says, 7 here, over 20 reports of triangles escorted by... That's the YouTube title of my channel. Okay, this is the 20, okay. I know, but what I'm asking is, I have a link in the vid description. Video, which description are you talking about? Okay, no intrinsic angular momentum. It's from the feature non. Okay, yeah, you're but another. Each rotation is right. Ken Wheeler. Yeah, Ken Wheeler. But the thing is, you have to be careful. Even the rotation, it's like what experiments matches or not. But at the end of the day, we need to literally create free energy. So this guy's over 20 reports. I'll subscribe to your channel. Okay. Trump is still child. R word. Or big stuff. I'm gonna go back to this setup here. Over 20 reports. Okay, but I want to know where's the images you took. Currently by 20 escorted by military jets. Okay, that's the report there. Oh, it's on your block spot there. Okay, I'll have a look there. I'll just put this here for later. Whoops. I'll just say this for later. I'll have a look at this later here. Add this to my later section. All right. Anyways, guys, I'm gonna close some stuff. Yeah, I think we're pretty much done. Yeah, so that UFO, the interesting about that, but you definitely got to follow my Telegram, but also on a Hive blockchain. I started putting this guy's work on here. So Peter Barron, the guy who saw UFO on 9/11, he said it matches the one on 1984 Olympics. So this is the one I used Grok AI based on his description. He says it looks like it, and he says this is like a nighttime version of it. And it's the one at the 1984 Olympics. Anyways, guys, that is all for today. I gotta head out, and yeah. So anyways, thanks for joining, and yeah, next week. So I'll be back in 2 weeks on these. I'll do every other stream. Next week I'll be doing some more Tesla coil experiments, so on behind the scenes. Anyways, guys, thanks for. Okay, then this is. Alright, guys. Anyways, thanks for watching, and that's all for today. I saw the lights. I didn't detect. I saw lights coming from Horizon. Logically ruled out possibilities. Okay. Please make a Grok AI. Yeah, please make an AI image of the UFO that matches your description. And send it to me at contact. Yeah, again, no worries about the photo, but you can use AI to literally render it exactly how you did, and then keep modifying until you get the right one. Anyways, guys, thanks for watching, and have a great day. Great day. Okay, as I'm gonna hang up. There's already an AI image that makes it. Yeah, I know, but just send me it that makes it. Send me exactly what you saw. Like what I'm trying to tell you is just send me exactly what you saw, and then you have your name and word so that I know that it's like an actual witness one. For example, Peter Barron. Peter Barron is this guy here. I literally talked to him for 2 hours, and he got a description. This is it. This is how it looks like. This one here at the bottom. I made AI. I kept sending it backwards and so on. My blog. Okay. Anyways, I'll read your blog. Okay, I'll read it. I'll read it. Thanks. All right. Anyways, guys. I'm ending the stream in 3, 2. What's it called? Anyways, adios, guys. I'm ending stream 3, 2, 1. Ciao. And stream, and then start recording.